In this video, I am going to explain geometrical meaning of the zeros of linear polynomial as well as quadratic polynomial. Now, ax plus b, where a is not equal to 0, is a linear polynomial. A polynomial of degree 1, where a is not equal to 0, is a linear polynomial. Why we write a is not equal to 0? Because if a is 0, then this becomes 0, and this is a constant polynomial. So ax plus b, where a is not equal to 0, is a linear polynomial. Ax square plus bx plus c, where a is not equal to 0, is a quadratic polynomial. Now, this is a polynomial of degree 2, and this is a quadratic polynomial. And here a is not equal to 0. If a is equal to 0, then it is bx plus c, then it is a linear polynomial. Then it becomes a linear polynomial. So ax square plus bx plus c, where a is not equal to 0, is a quadratic polynomial. In this video, I'll discuss geometrical meaning of the zero of these two polynomials, linear as well as quadratic. First, I'll discuss linear polynomial. I'll draw the graph of this linear polynomial. Then I'll discuss geometrical meaning of the zero of this polynomial. On the next page, I'll draw the graph of this linear polynomial. I'll take one example, 3x plus 6. This is equal to px. It means y is equal to 3x plus 6. On the next page, first I'll draw the graph of this polynomial. Then I'll discuss the geometrical meaning of the zeros of this polynomial. Now y is equal to 3x plus 6. I'm going to draw the graph of this polynomial. If x is 0, then y is equal to 6. If y is equal to 0, then x is equal to minus 2. So its graph is, let this point is 0, 6. X is 0, y is 6. This is the point where x is 0, y is 6. And this is the point where x is minus 2 and y is 0. Join this point. So this is the graph of the polynomial 3x plus 6. Now, let this point is A. So A is a point where the graph of this polynomial 3x plus 6 cut the x-axis. I'm going to find the zero of this polynomial. Let k is the zero of the polynomial. It means if k is the zero of this polynomial, then pk is 0. Pk is 0, it means 3k plus 6 is 0. It means 3k is equal to minus 6. It means k is equal to minus 6 by 3. That is equal to minus 2. It means k is equal to minus 2. It means minus 2 is the zero of the polynomial 3x plus 6. Now, what we have seen here, minus 2 is the zero of this polynomial, and minus 2 is the x coordinate of this point A, where this polynomial 3x plus 6 cuts the x-axis. तो आपको क्या समझ आया यहाँ पर कि जो आपका जीरो होता है, जो इस पॉइंट का x कोऑर्डिनेट होता है, वो दोनों सेम होते हैं. So we will write here zero of the polynomial is the x coordinate of the point where the graph of the polynomial intersect the x-axis. एक बार मैं आपको फिर से बता देती हूँ. आपने इस पॉइंट को डिस्कस करना है. ये वो वाला पॉइंट है जहां पर ग्राफ और x-axis इंटरसेक्ट करते हैं. इसका जो x कोऑर्डिनेट होता है वही आपका जीरो ऑफ द पॉलिनोमियल होता है. वही पॉलिनोमियल का जीरो होता है. और यू कैन ऑल्सो से जो जीरो ऑफ द पॉलिनोमियल होता है वही x कोऑर्डिनेट होता है इस पॉइंट का जहां पर ग्राफ और x एक्सिस आपस में इंटरसेक्ट करते हैं. graph of a linear polynomial is a straight line and it will intersect x-axis at one point. So it has 1, 0. So a linear polynomial has 1, 0, has exactly 1, 0. So the second point is a linear polynomial has exactly 1, 0. What you have learned, ax plus b, where a is not equal to 0, is a linear polynomial. And minus b by a is the 0 of the polynomial. Second thing you have learned, graph of linear polynomial is a straight line. And it will intersect the x-axis at minus b by a, 0. It will intersect the x-axis at a point minus b by a and 0. And third thing, 0 of a polynomial is the x coordinate of the point where the graph of the polynomial intersect the x-axis. And the fourth point is a linear polynomial has exactly 1, 0. Now let me repeat it again. What you have learned here, ax plus b, where a is not equal to 0, is a linear polynomial. And minus b by a, it means minus constant term upon coefficient of x, is the 0 of the polynomial. Second point, graph of the linear polynomial is always a straight line and it will intersect the x-axis at a point minus b by a and 0. Third, 0 of a polynomial is the x coordinate of the point where the graph of the polynomial intersects the x-axis. Fourth, a linear polynomial has exactly 1, 0. A polynomial of degree 1 has exactly 1, 0. Now I'll discuss geometrical meaning of the zeros of quadratic polynomial. Ax square plus bx plus c, where a is not equal to 0. Now I'm going to take one example here. X square minus 2x minus 3. This is a quadratic polynomial. This is equal to px. So y is equal to x square minus 2x minus 3. I'm going to draw its graph first. First, I'm going to draw its graph. So if x is 0, y is equal to minus 3. If x is 1, y is equal to, if x is equal to 2, y is equal to 2 2s are 4, minus 4, minus 3. This is minus 3. If x is equal to 3, y is equal to minus 6. If x is equal to 4, y is equal to 5. If x is equal to minus 1, x is equal to minus 2, y is equal to 5. Now I'm going to draw the graph of this polynomial, this quadratic polynomial. I have taken a few values here and you all know how to take the values. So I have written the values in this chart. I'm going to draw the graph of a quadratic polynomial. I'm going to draw a rough sketch of these points. Now, graph of this quadratic polynomial is a parabola. If x is 0, y is minus 3. So -3, let it be here. X is 0, y is -3. X is 1, y is -4. Let this point is x is 1, y is -4. X is 2, y is -3. Let this point is -3. X is 2, y is -3. X is 3, y is 0. Let this point is x is 3, y is 0. X is 4, y is 5. So let this point is x is 4, y is 5. X is -1, y is 0. This point is -1, 0. X is -2, y is 5. This is -2 and 5. This point is -2 and 5. Now join this point with a free hand. So I have joined these points with a free hand. It is a parabola. And this point is -1, 0. And this point is 3, 0. Now this is the geometrical representation of a quadratic polynomial. Now I'm going to find the zeros of this quadratic polynomial. The zeros of this quadratic polynomial. Let k is the zero of this quadratic polynomial. It means pk is 0. It means k square minus 2k minus 3 is 0. It means k square minus 3k plus k minus 3 is 0. It means k minus 3 plus k minus 3 is equal to 0. It means k minus 3, k plus 1 is 0. So k is equal to 3 and k is equal to -1. Now 3 and -1 are the zeros of this polynomial, x square minus 2x minus 3. Now what we have seen here, now 3 and -1 are the zeros of this polynomial. Let me write it here. 3 and -1 are the zeros of this polynomial. And -1 and 3 are the x coordinates of these 2 points A and B, where the graph of this polynomial intersect the x-axis. 3 and -1 are the zeros of this polynomial, and -1 and 3 are the x coordinates of this point, where the graph intersect the x-axis. So what it implies, these points -1 and 3 are the zeros of the polynomial. If we see this graph, we can immediately say -1 and 3 are the zeros of the polynomial. And if we see these zeros, we can immediately say 3 and -1 are the x coordinates of the point where the graph intersect the x-axis. So on the next page, I'll write zeros of a quadratic polynomial are the x coordinate of the point where the graph of quadratic polynomial intersect the x-axis. I'm going to draw the shape of the graph of quadratic polynomial y is equal to ax square plus bx plus c. Shape of the graph of quadratic polynomial ax square plus bx plus c. There are 3 cases. On the next page, I'll draw the shape of the graph of the quadratic polynomial. So I have made the rough shape of these parabolas. So here, this parabola intersect the x-axis at 2 points. So it has 2 zeros. Here again, it intersects the x-axis at 2 points, so it has 2 zeros. Here it intersects the x-axis at one point. It means it has two equal zeros, or you can say it has 1 0. Again, it has 1 0. It doesn't cut x-axis at all. It means it has no 0. Again, it has no 0. So these are the three cases in which a parabola intersects the x-axis at 2 points, where it intersects the x-axis at 1 point, where it doesn't intersect at all. So here we will say it has 2 zeros, it has 1 0, it has no 0. So what it implies, a quadratic polynomial has at most 2 zeros. A quadratic polynomial has at most 2 zeros. Or you can say a polynomial with degree 2 has at most 2 zeros. Has at most 2 zeros. So in this video, I have explained geometrical meaning of the zeros of linear polynomial as well as quadratic polynomial.